This is the video demonstration for ECE 286 Exam 2 Part C. We're demonstrating problem number 1151. Here we're going to find the power equivalents for this circuit here on the left. We're going to find the power factor, the average power, the reactive power, the apparent power, and the complex power. So the first thing we need to do for this circuit is find I. To find I, we'll use Ohm's law. Calculate R here, and then plug it in, and we get I is this figure here. So the first thing we're going to find is the power factor. The power factor is the cosine of the phase difference between the voltage and the current in this circuit. So we plug that in, we find our phase here is 45 degrees, and then we've got 39.38 degrees here. It gives us a power factor of 0.99. So it's almost ideal. It's almost purely resistive. So what we can infer is that the apparent power will be almost the same as the average power. And we'll see that here in just a minute. So the next thing that we can calculate is the average power. And what the average power is the real valued power of this circuit. So we're going to use this equation here, which is half of the magnitude of the voltage and the current, and then the power factor. Plug that in, and we get 499.56 watts. We'll keep that in mind here in a little bit when we see apparent power. So we're going to switch things up a little bit. It's going to be easier for us to solve the rest of this if we look at the complex power first. So what the complex power is, it's the full power value for this circuit. And we're going to use VRMS and IRMS, the root mean square of the voltage and the current. So that's the first thing we need to do, is calculate those. Then we're going to use this equation here to look up the real valued part and the imaginary valued part. Plug in the numbers here, and this is what we get as the result. And if we'll look, this piece is the real value part, and then this piece is the complex power. This is the reactive power. And so pretty easily we can take that from here, and here we've got the complex power. Now if we're looking for apparent power is the magnitude of the complex power. And so we just take the magnitude here, and this is what we get. Now if we'll notice that Q is positive, and that means that the load on this circuit is slightly inductive, and so we have a slightly lagging power factor. We saw that 0.99, it wasn't exactly 1. And that's it.